Hi guys, so we've talked about if we have a strong acid or a strong base, but what if we have a weak acid or a weak base? Well, the first thing you're going to have to do is consult a table, or it will be given to you in the problem, where we have the Ka's, or the dissociation constants, for some of our weak bases or acids. This one happens to be acids. Here's the one we have in this problem, so it's 4.6 times 10 to the negative fourth. So my Ka equals 4.6 times 10 to the negative fourth. Next thing I'm going to want to do is to write out that equation. So HNO2 dissociates, and now this is an equilibrium, and I get H plus NO2 minus. And so if I start with a concentration of 0.100 molar, I'm going to use ice or rice if you prefer. And my reactions balanced. Here's my initial concentration, and this is when I first mix them together, and I'll have nothing of those two. Then I'll lose X here, I'll gain X here, and I'll gain X here. And this is just a special case of equilibrium. It happens to do with acid-base dissociations. And so this would be 0.100 minus X, this would be X, and this would be X. If I'm writing the Ka expression, or the equilibrium expression for this reaction, same as any other equilibrium, would be the concentration of hydrogen ions times the concentration of NO2 ions divided by the concentration of HNO2. Now we are going to, since this number is pretty small compared to this number, I'm going to assume that X is much smaller than 0.100 molar. And that's based on this exponent here. So I would then put in, so I can then delete my minus X, so it would be X times X divided by 0.100 molar would equal 4.6 times 10 to the negative fourth. So X squared is going to equal 0.100 times 4.6 times 10 to the negative fourth, which would then become 4.6 times 10 to the negative 5. So now I can take the square root of that number, because this is still X squared. And so I'm going to put in my calculator second square root, 4.6 second EE negative 5 equals, and I get for X that it's 0.0068. So that would be my hydrogen ion concentration, and it would also be my NO2 ion concentration. I'm going to go back and change this problem a little bit, and let's just make it 1.0. Get rid of this second 0. And so that would make this, if I subtract it from 0.10 minus 0.0068 equals, and it would affect it, so I could not make this assumption. This assumption is not valid, because I would get my concentration of HNO2 would equal 0.0932 molar when I subtract it from its original concentration, and that does not round up to my original concentration. So I would say this is invalid. But for the sake of argument, we're going to go with it today. So now if I wanted to calculate my pH, since this is my hydrogen ion concentration and my NO2 concentration, my pH would equal negative log of 0.0068. So negative log 0.0068 equals, and I get my pH is 2.17. Because again, my significant figures are 2. That's how many decimal places I get. So, hope that helps you with these kinds of calculations. Again, it relies heavily on what we did in equilibrium, which I know was not a strong suit for some of you. So anyway, thanks for listening.